just a water system. So we have one set up above ground, so you can see that. Then we're going to collect a sample and go over to the lab. The Water Bureau has its own lab. It's a certified lab where we do our own water quality testing. There are some things we send out, but for the most part we do our own routine testing. So we're going to visit that. Then from there we're going to break up into 3 groups. We're going to visit the control center, from which we can control the entire system using computers. And one group will come back here and visit the meter shop, so you can see how they test meters. And one group will go and will do a vault entry, so you can see how we test the air quality in the vault and the apparatus that we wear to get in there. And then everybody will get to do all 3 of those things. Then we're going to meet back in our auditorium at the end, and we have a little presentation for you, and I'll also be talking about how to apply for jobs at this city.
Nice.
So, how's that sound?
That sounds good. All right.
This is the typical example of an entire
This
water
is a
system.
main, obviously.
Main right here.
And you can see that the size changes back and forth, and we use these bell clamps to reduce and enlarge it. The pipe is ductile iron. Originally we used cast iron back in the early 1900s. Cast iron tends to be very brittle though, and so when you have temperature changes it can crack and break. Ductile, as the name implies, is more flexible, and so you have less, we hope, less breakage. We haven't actually had it in the ground long enough to know how long it will last. Our chief engineer always tells us, though, that Portland is a great place to be a pipe because the soils and there aren't the huge temperature fluctuations that you find in other places. When we have a really cold snap during the winter, then as it thaws, we tend to have a lot more main breaks. But we haven't had that for the last couple of years. This is what's called a valve. And we use these, they're placed strategically throughout the system so that, for example, if we had a break here, we could shut this off and there wouldn't be any water in there. Now this is just a run that's going to a hydrant, but they're placed throughout the system for that purpose, to shut it off so that we can isolate sections of the main and then repair it. I don't know if any of you watched, what was it, Barbara, with Drew Carney?
Out and About.
Friday morning
show.
for the Women in Trade show.
Yeah.
And we had some women out there demonstrating how to fix a main break. Now, in that case, we didn't turn off the water. We left it on and then put a clamp over it and tightened the clamp down to fix the break. That's one way of repairing it, depending upon the kind of break that it is. This is the meter, of course, and everything on this side of the meter, the side that where your house is, it's kind of oddly put together here, but this is what you own, and you take care and you manage that. We own everything up through here. And the meter size, and this is a 3/4 inch meter, which is pretty standard for a house, a single dwelling residence. Bigger buildings are going to have much larger meters, sometimes multiple meters, so they have multiple intakes into the building. So for example, a hospital might have 3 or 4 places where water comes in, so that if one of them had to be shut down, the facility would still have water. But your house only has one. If you ever had to shut it off at the meter, you could come out here and do it right here. There's a tool. It's pretty hard to do. You could do it with something that you clamped on there and turned it, but it can be pretty hard to do. This is copper. We use copper in between the main and the meter, and then this piece coming out is going to be copper. You may or may not have copper inside your house, depending upon when it was built. Some people have PVC. If it's an older home, you can have galvanized, which is not the world's finest. I lived in a house with galvanized, and I couldn't drink the water. I had to put it in my refrigerator because it tasted bad from the galvanized pipe. So, any questions about this setup? This is the kind of thing that you would have for a larger setup. You can see that this is a much larger copper pipe coming off of the system, and there would be maybe even 2 meters here.
About at the dead end here, is this a sampling station?
Not necessarily. It may just be a standpipe. Sampling stations are not usually at dead ends if we're looking for water quality, although we could take a sample from there, but we might use that to flush, for example, because dead ends do get nasty. The Portland water system is unfiltered, which means that doesn't mean it's untreated, but it's unfiltered. So there can be a lot of sediment in the water, and so when you have a dead end, you kind of tend to run into a place where sediment collects. There can also be I don't know what I was going to say. When we get too much sediment, that's one of the reasons why we have to stop using the water from Bull Run and start using the water from the well field, because there is a measure, and in fact I believe that's one of the things that Marcia's going to show you in the lab, is how we measure for particulates in the water. And when it gets above a certain point, I want to say 7 NTU, then we can't use that water. And that happens in the Bull Run when we get lots and lots of rain, because it's just a lake with dirt, and so you can get a lot of rain, and then you wash sediment into it, and it settles down pretty quickly. But that we have to wait for that to happen, and then we can turn on the well field as a supplement. We usually don't run the well field all by itself, except in those instances when there's something going on up in the Bull Run that doesn't allow us to use that water.
What is your volume? How much are you distributing water?
It depends. In the winter, I think we do, and somebody correct me here if I'm wrong, about 75, 80 million gallons a day. Can go up higher in the summer with higher usages. Over 100 million. One of the great challenges is figuring out how much water people are going to use, and we have to do that a year in advance, and that's how part of the formula that we use